Hello everyone. In this video, we're going to do the register level coding in the STM32Cube IDE. First of all, we have to create a new STM32 project. All you have to do is just type in the part number of your board. Mine is STM32F103C86. There we go. Next. Just type in the project name, whatever you want. Like, I'm gonna put test and click finish. Well, yeah, the project is made, and since we are going to the register level coding, we don't really need this IOC file, so click close. Just open up the main C file. And you don't even need this kind of code as well, so just erase it all. There we go. Now we're going to light up this LED over here. In my MCU board, I have LED over here and it's right connected with port C13. And if we set high voltage over here, the current will not go through this path. But on the other hand, if we set low voltage over here, then the current will go through this path. So therefore, LED will light up. So that's our strategy. Now let's move on to the register level coding part. All you have to do is just find out the base address from the reference manual and find out the offset number as well. And so to make the real register, you have to simply add the base address and the offset number. It's just super simple. And I don't really go that deep with the grammar part, so just so you know. And then we're going to enable the GPIOC clock, which is step 1. And we're going to set the output mode of the GPIOC, especially port C13. And we're going to set the push-pull mode and 10 megahertz with the maximum speed. And if you set the flag with number 1, I'm going to light up the LED on my MCU board. Otherwise, I'm going to turn off the LED on my MCU board. So that's the entire recap of my strategy. And let's move on to the reference manual. To find out the RCC base address, you have to take a look at the reference manual first. There we go. This is the entire memory map about the whole chunk of theme features, I guess. So especially for the reset and clock control, you have to copy this number, this address for the base address over here. Just so you know, UL stands for the unsigned long, which is the variables type, one of the variables type. And what about the offset number? Well, if you go to the reference manual, you can easily find the offset over here, which is APB2 enable register which is related to GPIO-C over here, as you can see. So just copy and paste. And then let's move on to GPIO-C, which is step 2. So there we go. GPIO-C is the base address. It's over here. So copy, paste. And what about CRH, which is control register? So if you go to the reference manual over here, you can easily see the offset number over here. There we go. The last one is output data register. So let me see. There we go. Copy and paste it. And yeah, to make the real register over here, you can simply add the base address with the offset number over here. So yeah, that's all for the initialization of the registers. Well, let's move on to the main function over here. First things first, we have to enable the GPIO-C clock first. So if we take a look at the register over here, we have to make sure to write down 1 at 4th beat over here. So it is, the hexadecimal number is 4 beats. 1 hexadecimal number is 4 beats. So this is 1 chunk, and this is 1 chunk, and so on. So, but all we have to do is just set this part. So if we transform it into hexadecimal number, it should be 00000010. There we go. That's all. Since the reset value of this register is 0, so you don't really need to clear up this part. You just write it down 1 over here. Now let's move on to step 2, which is related to port configuration. If you go to the reference manual, since I'm using the PC13, so all we have to take care about is this part. So since we are using the push-pull mode and 10 megahertz max speed, we have to write down 0, 0, 0, 1. But before we write it down, since the reset value of this register is not 0, so we have to clear up this part just in case. So it should be 00F0 0000. There we go. And then let's put the number over here. It should be 0010, and the rest of them is all 0. There we go. Now let's move on to the last part. To turn on the LED, we have to set the low voltage on the port C13. So if we take a look at this reference manual over here, we have to we have to put the 0 in this part. This is 13th beat, so all we have to take care about is this part. So this bit should be 0. So, but since we're using the reverse operation and the AND operation, we have to put 1 in this part, and the rest of them should be all 0. So if we fill up the all 0 in this part, and this should be all 0, and this is whole chunk, this is one chunk, this is one chunk, this is one chunk. So if we transform the bits into hexadecimal number, it should be 0, 0, 0, 0, 2, 0, 0, 0. There we go. I'm going to write down 0, 0, 0, 0, 2, 0, 0, 0. There we go. Right. In contrast, to turn off the LED, we have to set the high voltage on the port C13. So just simply copy and paste this number directly in this part. So this is all about the code, the register level coding. So if we just simply build this code, the build is completed without any other errors. Now I just uploaded my code on my MCU board. So to control the LED, we have to register the flag in this live expression tab. So now the value is 0, so the LED is off over here. But if we set 1 in this live expression tab, you can see the LED is turned on. Again, if we put 0 in this part, the LED is turned off. Well, this is all about the demonstration today, and I hope you find it very useful through this video. So yeah, see you on my next video. Bye guys.